Okay, today guys, we're going to discuss on how to find the product in the quotient of the functions. Okay, so we have here two given functions, f of x, which is equal to 2x plus 5, and g of x, which is x squared minus 1. So this time, let us find the value of f or f functions, f of g of x. So in this representation, so it means that we're going to multiply. Okay, so we're going to multiply f of x to g of x. So what we're going to do is we're just going to substitute the value of our f functions, which is 2x plus 5, and multiply to g function, which is x squared minus 1. So in this case, as you observe, we are going to multiply two binomial. So in multiplying two binomial, so we're going to use the FOIL method. So f is the first term, o is the outer term, I is the inner term, and L is the last term. So let us do the first term. So meaning, we're going to multiply the first term of the two binomials, which is 2x multiplied to x squared. So this is equal to 2x cubed. Then outer, so meaning we're going to multiply the outer term of our two binomial, which is this one, 2x times negative 1. So 2x times negative 1 is negative 2x. The inner one, so which is the 5 multiplied to x squared. So this is now equal to positive 5x squared. And the last one is 5 multiplied to negative 1. So this is equal to negative 5. Okay? So here, simplify by combining like terms. Since in this solution, we don't have like terms, so we are just going to arrange the terms based on the highest exponent to lowest exponent. So our highest exponent here is 2x cubed, then followed by positive 5x squared, then negative 2x, and the constant, which is negative 5. So we can say that this is now the product of these two functions. Okay, so this time, let us have another example on how to find the product of the two given functions. So we have here f of x, which is negative x plus 3, and we also have here given g of x, which is 4x squared minus 3x plus 6. So this time we're going to find f of g of x. So it means that we're going to multiply the f functions, f of x, to g of x. So what we are going to do is we are just going to substitute the value of our f of x, which is negative x plus 3, and we're going to multiply it to our g of x, which is 4x squared minus 3x plus 6. So in this case, we are not going to use the FOIL method because the FOIL method is only applicable if we are multiplying two binomials. Since in this case, we are multiplying binomial by trinomial, so we're going to use the distributive property. It means that we're going to multiply this first term or distribute this first term to our second function, and this second term and distribute it to the second function. Okay, let's do this. Okay, so distribute negative x times 4x squared. So we know this is negative 4x cubed. Negative x times negative 3x. So we know that this is equivalent to 3x squared positive. Then negative x times positive 6 is negative 6x. Since we are done distributing the first term, we're going to distribute the second term. So 3 times 4x squared is equivalent to 12x squared, positive 12x squared. Then 3 times negative 3x is equivalent to negative 9x. Then 3 times positive 6 is positive 18. So we have here now. So what we are going to do is we are going to simplify this one by combining like terms. So as you observe, we have here two like terms, which is 3x squared and 12x squared. So bring down the rest. So we have here 4x cubed, then 3x squared plus 12x squared is equivalent to 15x squared, positive 15x squared. Then the x, we have here negative 6x, which is also a like term, and negative 9x. So we know this is equivalent to negative 15x. Then the constant, which is equivalent to 18. So we have now here the product of these two given functions, which is negative 4x cubed plus 15x squared minus 15x plus 18. So this is now our final answer. Okay, so this time, let us now try to solve this one. So feel free to pause this video if you want to and try to solve this given function. So we have here f of x, which is 2x plus 1, and g of x, which is x squared minus 3x plus 4. Find the value of f of g of x in this situation. Okay? Feel free to pause this video and do it in your scratch paper. Okay, so this time, let us try to solve. Let us check if we have the same answer. So we have here f of g of x. So meaning we're going to multiply the product of f of x, or we're going to multiply f of x to g of x. So we're going to substitute the value of our f of x, which is 2x plus 1. We're going to multiply this to x squared minus 3x plus 4. So same as usual, we cannot apply the FOIL method here since we are multiplying binomial by trinomial. So what we're going to do is we're going to use the distributive property. We have to distribute this first term to our second function and the second term to our second function. So let's do this. So 2x times x squared. So we know this is equal to 2x cubed. 2x times negative 3x. So this is equal to negative 6x squared. Then 2x times 4 is equivalent to positive 8x. And 1 times x squared. So we know this is equal to positive x squared. 1 times negative 3x, so negative 3x, and 1 times 4, so this is equal to 4. Then simplify by combining like terms. So we have here like terms, the negative 6x squared and x squared, then 8x and negative 3x. Then bring down the rest. So we have here 2x cubed, add negative 6x squared plus x squared. So we know this is equal to negative 5x, and 8x plus 8x plus negative 3x. So we know this is equal to positive 5x. Then the constant, which is positive 4. So we have here now the product of these two binomial. So if you got the same answer, congratulations. And if you have question, feel free to comment it below. Okay, so today guys, we're going to discuss about division of function. We have here two given function, 2n minus 1, and g of x is equal to n plus 3. So let us find a f of x all over g of x and B, g of x all over f of x. So we know from our previous discussion, so we say that in division of functions, our denominator must not equal to 0 because we know any number divided by 0 is equal to undefined. Okay, so this time, let us process this letter A given. So we have here f of x all over g of x. So same as usual, we're just going to distribute the value of our first function to f of x, which is 2n minus 1 all over g of x, which is n plus 3. Okay? So after that, you have to factor first or simplify in a simplest form our numerator and our denominator. Since the 2n minus 1 and n plus 3 are in simplest form, so there's no need to simplify this one. So we can say that this 2n minus 1 and n plus 3 is our final answer. So we let us remember, guys, that we should not cancel the n here in our numerator and n here in our denominator because they are just common term, not a common factor. Okay? So in this case, in our final answer, we have to indicate that the value of our n must not equal to -3. Since we know if our n will be equal to -3, our denominator will become equal to 0. Because we know n plus 3, it will become to 0 if and only if the value of our n is equal to -3. So -3 plus 3 is equal to 0. That is why we have here the restrictions where the value of our n must not equal to -3. Okay? So here, let us answer this one, letter B, which is g of x n plus 3 and all over f of x 2n minus 1. So same as usual, distribute. So we have here g of x n plus 3 and our denominator, which is f of x 2n minus 1. So therefore, as we say, so this is enough. This is in a simplest form already, our numerator and the denominator. So let us determine when the value of 2n minus 1 will become equal to 0. So this will become to 0 if we have here 2n minus 1, then transpose, this is 1 all over 2. So our n is equal to 1/2. This means that our denominator will become equal to 0 if and only if the value of our n is equal to 1/2. That is why our restrictions here, where the value of our n must not equal to 1/2. Okay? So this is now our answer. In A, we have 2n minus 1 all over n plus 3, where n must not equal to -3. And in B, we have here the final answer, n plus 3 all over 2n minus 1, where the value of our n must not equal to 1/2. Okay, so let us have here another example. So we have here given function h of x is equal to 4x plus 20 and k of x, which is equal to 2x plus 8. So let us find the value of h of x divided by k of x. So same as usual, we're just going to substitute the value of our first function, so which is 4x plus 20, and our denominator k of x, which is 2x plus 8. So in this case, let us simplify our numerator and denominator. So by getting the greatest common factor, the GCF of our numerator is 4. So this is 4. Then 4x divided by 4. So we know this is equal to x. Then 20 divided by 4 is equal to 5. So this is positive 5. In our denominator, the greatest common factor in our denominator 2x plus 8. So this is equivalent to 2. So 2x divided by 2. So we know this is equal to x. Then 8 divided by 2. So we know this is equal to positive 4. So in this case, we have here a common factor which is 4 and 2. So this time we can divide these two. So we know 4 divided by 2 is equal to 2. Then we have here x plus 5 all over x plus 4. Okay? Where the value of our x must not equal to negative 4, because we know in our denominator x plus 4, the x plus 4 will equal to 0 if and only if the value of our x is equal to negative 4. So therefore, this is now our final answer. Okay, so with of the same given function, so h of x, which is 4x plus 20, and k of x, which is 2x plus 8. So this time, let us find the value of k of x divided by h of x. Do they have the same answer? So let us check. So same as usual, we are just going to substitute the value of our k of x. So our k of x is 2x plus 8. So we have here 2x plus 8, and our denominator, which is h of x, in a form of 4x plus 20. So this is 4x plus 20. So same as usual, we have to simplify our numerator and our denominator by getting the greatest common factor. The greatest common factor of our numerator is 2. So this is 2 times x plus 4. Okay, because 2x divided by 2 is x. Then 8 divided by 2 is 4. Okay, so that is the process. So how about our denominator? So our GCF is 4. So we have here 4. 4x divided by 4. So we know this is equal to x. Then 20 divided by 4. So we know this is equal to positive 5. So we have here now the greatest common factor, the 2 and the 4. So we can simplify this 2 as 1/2. So we have here 1/2. Then our parentheses, so we have here x plus 4 all over x plus 5. Or we can say that this is equal to x plus 4 all over the quantity of x plus 5. So what will be our restriction now? Where the value of our x must not equal to what? Okay, so this time let us determine when this our denominator will become equal to 0. So when the value of our quantity of x plus 5 will become equal to 0. So distribute 2 times x is this is 2x. Then 2 times 5, this is 10. So when this whole thing become equal to 0. So we have here 2x, which is transpose the positive 10. So this is negative 10. So the divide both sides by 2 to get the value of our x. So the value of our x is equal to negative 10 divided by 2 is negative 5. So therefore, in our restriction, we should not let the value of our x become equal to negative 5, because we know if the value of our x here will become equal to negative 5, so the whole thing will become undefined, because negative 5 plus 5 is 0 times 2 is 0. Okay, so that is the final answer. We have here x plus 4 all over 2 quantity of x plus 5, where the value of our x must not equal to negative 5. So this is our final answer. Okay, so let us have here another example. So we have here given a function f of x, which is x squared minus 1, and g of x, which is in a form of x plus 1. Then here, find the value of g of f of x. So the same as usual. So this is also the same as g of x all over f of x. And same as usual, we are just going to divide our numerator and the denominator. So we have here our numerator, x plus 1, all over our denominator, x squared minus 1. So in this case, simplify our numerator. So this is in a simplest form already. So we have to write it here, bring down. So x over 1. And this one, let us also simplify this one. So we know this is in a form of sum and difference of a two perfect square. So if we're going to factor this one, this will become x plus 1 and x minus 1. So in this case, we have here common numerator and denominator. So we're just going to cancel this one, cancel this one. So we will gonna have 1 all over x minus 1, where the value of our x must not equal to what? Okay, so let us determine what will be the value of x here, x minus 1, that will make this expression become equal to 0. So we know x minus 1 will become equal to 0 if the value of our x is equal to positive 1. Okay, so here we can add where the value of our x must not equal to 1, because we know x minus 1 is equal to 0 and 1 all over 0 is undefined. So this is now our final answer.